Okay, so in our lectures to this point, we've talked about the universe expanding from a singularity, what we call the Big Bang. As it expanded, then forces separated out. We began to get the individual forces, the freezing out of those forces, overshooting what we call a false vacuum or supercooled state. As the strong force freezes out, you get inflation. The universe rapidly expands. And then you start making more particles, and you start eventually getting nucleosynthesis, creating the very first atoms, very first nuclei rather, and then recombination. Really, as I have said before, it should be called combination, and that creates the first atoms, in which the electrons get grabbed up by the nuclei, and now you have the first atoms. You have the dark epoch, not much is happening there. The universe is simply expanding. You get a swarm of atoms. As they're cooling off, the universe goes from visual to infrared. Nothing is visible. Finally, get the first stars, and then more stars, and yet more stars, and then a whole bunch more stars. The stelliferous era. And so we're still in the stelliferous era. We're still making stars and galaxies. Galaxies are still coming together and colliding. As I'd said earlier, the Milky Way is still probably in the process of forming. We got these clouds of gas spiraling into the galaxy. We've got the Andromeda Galaxy on a collision course with us. Eventually, the entire local group will be swallowed up into one big, what we call fossil cluster, and so, or fossil group. And so that's going to be the entire, that the whole thing. Okay, and so the next question: what about the future of the universe? Two possibilities. One possibility, and what was the leading idea when I was in college, was the universe will expand to a point, gravity will win, it will stop the expansion, the entire universe will fall back in on itself, what we call the big crunch. Essentially, the whole universe squeezes back into a singularity, and as it gets hotter, squeeze and squeeze, hotter and hotter and hotter, back to a singularity, we get a hot end. Okay. What happened at that point? They kept arguing. They said, does the universe just like start, stop, and then we're done? That's it? Or does it squeeze into a singularity, which then expands to another universe, the big bounce? And so an oscillating universe. And so there were speculations there may have been like nearly infinite number of universes before ours, that ended as a singularity. Then ours became the next universe, and then ours will end as a singularity, and another universe will form. So that was one possibility, and that was kind of an idea they kept arguing about. The other possibility was it never stops expanding, keeps going forever. Again, we seem to have right that critical density, and so they were arguing about that possibility. In which case, something called the heat death of the universe happens, and things get so far away from each other as the universe expands that things quit interacting. And so if they quit interacting, then nothing else ever happens, and so the universe kind of dies of boredom. And so these were the two competing ideas. Well, the problem is dark energy makes the universe accelerate the expansion. If we're accelerating expansion, then that means we're not going to slow down, and we're not going to go into a big crunch. No bouncing universe. We are in fact going to expand forever. So let's go into what does that mean. Well, we're in the stelliferous era right now. So as the universe expands, what's going to happen is we're using up interstellar medium to make stars. Eventually, we're going to use up all the interstellar medium and not many stars to make. And so the stars that are there are eventually going to die. And even the little red dwarfs are eventually going to run out of steam, and they're going to die. And so eventually, all that's going to be left of the universe are white dwarfs, neutron stars, and black holes. And there'll be a few stray particles out there. Eventually, the universe is going to expand so that everything outside of our local group has expanded away from us, and we can no longer interact with it or even see it. Again, the bigger the space between us and there, the faster it expands, and so eventually the local group's going to be the entire universe. And so what makes up the local group will be held together by gravity and make just a fossil cluster of dead things. White dwarfs, neutron stars, black holes, and then just a few stray particles. Eventually, though, protons will decay. They're not going to last forever. And so white dwarfs are going to decay into neutron stars. Eventually, neutrons will decay. And so neutron stars will collapse into black holes. So there'll be nothing left except for black holes. We call that the black hole era. Now, black holes will last for a really long time, but eventually Hawking radiation will cause them to decay. So after 10 to 100 to 10 to 150 years, there's not even a name for numbers that are that big. So these are ridiculously huge numbers. After that amount of time into the future, though, then Hawking radiation will have decay, would have caused all the black holes to decay. Well, now you have all these individual particles spewing out, particles or radiation, but those particles are now so far away from each other, they're never going to come back together to fuse or do anything else, and we know that they will eventually decay themselves. They're going to decay, and eventually all that's going to be left is light, photons. Well, the problem is the universe will keep expanding, and as the light's traveling across the universe is expanding, and so the wavelengths get longer and longer and longer. Well, if you stretch it long enough, you stretch it to a straight line, and then it's not a photon anymore. It's not light anymore. Eventually, you're going to stretch everything into nothingness. Once the light's been stretched all the way to nothing, then the universe once again enters kind of a dark age. And once again, there's nothing there, except now there's not even the beginnings of the universe. There's nothing that can ever happen. It's just going to be dark forever and totally empty. At some point, even the background energy of space is going to drop off, and you're going to quit having virtual particles, possibly. And so there'll be nothing, absolutely nothing, just a totally empty void where the universe used to be. And we call that the heat death of the universe. The term heat death actually goes all the way back to Lord Kelvin back in the 19th century, and his idea was that heat goes from hot to cold. That's how energy happens. Thermodynamics is based on energy flow and work being done by energy flowing. In fact, work is in physics defined as the change in energy. And so the heat death of the universe would occur when everything has equal amount of heat, equal amount of energy, and now energy doesn't want to go from one place to the other, and so stuff quits happening. That was his idea, the heat death of the universe, but if you consider the heat death of the universe from the end of the photon era, then Kelvin's idea of heat death seems pretty tame. And so, but eventually the photon era will come to an end, and then there is nothing, just nothing, period, nothing, end of the universe. Nothing ever happening ever again. And so just void that's empty. So that's the end of the universe.